So I played a little trick on you in the last video. I very carefully chose things where it all came out nicely. You'll notice, yeah, that factored with that. And yeah, then I could write that. It all worked out. That was a multiple of 2, or that had a 2 in it. Sometimes it doesn't work out quite as gracefully. But we can still use our rewriting strategies to manage to complete the square, even if life gives us somewhat uglier trinomials to start with. This one starts out pretty well because I've got 3 times x squared, and 15 I can rewrite as 3 times 5. So factoring out that 3, that's going to go fine. I can do that. Here I go. X squared plus 5x. But now, 5, for those of you who, remember how dividing things by 2 works, 5 is an odd number. So I can't write it as like 2 integers and one of them even, one of them 2. I can't write it would go 2 times 2 is 4, and 2 times 3 is 6, so not happening with this 5. So I need to use a little more algebra strategy to get there. But that's okay, I can do that. Well, I'm going to do the math teacher thing where I leave a little space because I know where I'm going. Just like I've needed to strategically add weird-looking zeros, I'm going to need to strategically multiply by weird-looking ones, because I really need a 2 here, and I can't just multiply by 2 in the middle of this mess because I feel like it, but I can multiply by 1, and the form of 1 I will choose is 2 over 2. But I'm not going to just go ahead and actually do that multiplication because I really want this 2. This 2 is like the entire point of this exercise. So instead, I'm going to do a little more rewriting. So I have 2 times 2 over, that would be 5 times 1. And rather than multiply the tops and multiply the bottoms and be done with it, let's just write the whole thing like this for a minute. Well, I could have this 2 just be over 1. I could pull it out and have it be just 2 over 1 or just plain 2, and that would leave me with 5 halves. And you don't need to show all of these little steps every time. I'm trying to break this down into really small pieces so you can see what I'm doing and why. Because really, you could go straight from here to here. And at some point, that's exactly what you'll do. But I want you to kind of have a sense of where that fraction came from. And so I tried to show a little extra work. And so now it's kind of matching our template. It's ugly, but I can find B. It's just gonna be ugly. Hey, math pun, math pun. So my B is going to be 5 halves. My B squared will be, I don't know why I didn't do that one a cursive B, but sometimes I just make decisions. 5 over 2 squared. So that's what I'll have to add and subtract to make it a zero pair, because that's the only thing I can add and subtract is zeros, because it's an expression, not an equation. Can't just do stuff because I want to. To have a reason why it works. So I have to use those identities. Oh, -7, I haven't forgotten about you. I'm just ignoring you for now. And just like before, it's important for me to remember that this entire thing is squared and then subtracted, that I'm doing my order of operations. So I like to add in that extra set of parentheses to really remind myself about the order of operations. And I also want to point out, I've been very careful to include a multiplication symbol here, because this is multiplying this number by this number, and this is not a mixed number. If I had 2 and a half, that would be saying 2 plus 1/2. But I'm not saying that here. I'm saying 2 times, in this case, 5 halves. And so I need to keep that symbol there to make it really clear that I am multiplying these numbers rather than adding them, because our convention when we write a mixed number is that I am adding them. And that is one of many places where math notation is just a little bit, you have to know what they mean to understand what's going on. So I'm going to go ahead and do some work there. I'll use the quotient property and go ahead and pop that on the top and the bottom of my fraction. And close my parentheses there. And that -7 is just hanging out. I will get around to subtracting 7 one of these days. But I have a little more math to accomplish in these parentheses. And I am showing perhaps a few more steps than you will choose to show in your own work, because I want you to really clearly see where everything's coming from. But you can be strategic about which of these steps you show and which of these steps you just kind of charge right ahead and do. So 5 squared is 25, 2 squared is 4, and I finally don't need my parentheses to remind me to do stuff. And then -7. So now I can do my partial use of the distributive property again, where I keep that part. So 3x squared plus 2 times 5 over 2 times x plus 5 over 2 squared. But now I distribute that 3 to this. And I'm going to go ahead and at this point deal with that minus sign, and I'll stick it on the top rather than the bottom. Could have been on the bottom. It can't be on both because that would be different. But I could have put it with the 25, could have put it with the 4. Doesn't matter. So now this matches my template. It's ugly, but it matches. So I can rewrite this as x plus 5 halves squared plus 3 times negative 25 over 4 minus 7. And then I need to get my constant term cleaned up a little bit because that is not great. Okay, so this part is no longer going to change because I have completed the square. 3 times negative 25, so that would be negative 75 over 4 minus 7. Then I will need to get a common denominator with this, so I will need to multiply 7 by 4 and get 28 over 4. So I have negative 75, and I take away 28, and I get negative 103 over 4. And it is definitely acceptable to be using a calculator to do things like deal with these numbers. That's totally reasonable. I worked this out in advance so that I wouldn't be fumbling around with those calculations during this video, because that's not the focus of this video. So I'm going to end this video here and do the next example in another video, just because this has gotten kind of long. And so I think it might be helpful for you to stop here and just see this one in this video.